Today, my topic is about generalized offline training of spiking neural networks. And the importance of my talk is the title only. And then, so I have a question. This is the third day of the workshop. If you're a deep learning guy or girl, do you still think, I don't know how to operate a spiking neuron? Or I don't know how to write a code on spiking neural networks? Or I'll never touch a good hardware like Spinnaker. If you're still thinking about like that, this is your solution. So my method is to train a spiking neural network offline on your artificial neural networks. So very simple. If you use ReLU, like rectified linear units, or whatever your deep learning architecture is, you can use my method. Simple. So you train your network on your traditional artificial neural networks, and then I use the weights, move it back to spiking neurons without any conversion, and boom, it works like that. And you can run it on Spinnaker directly. So it's simple as like that. But if you're interested in how this works, I'll talk about something about the methods, but you don't have to care. And so here we see the fundamental difference between an artificial neuron and a spiking neuron. So you see, if you see closely, the input and output of a spiking neuron are spikes. And the input will form a noisy current flowing into the spiking neuron. And then the membrane potential changes, like Mihai has told us today. And then, but if you compare with the artificial neuron, the input-output, the form are totally different, and the computational dynamics are different. And how? So there are two problems here: how to model a good activation function to model a spiking neuron, and then how to use map the abstract artificial activation function to real physical units in spiking neurons. So the first part, I proposed the activation function noisy self plus, and it solved the first problem of modeling spiking neurons. And the second one is using a parametric activation function. It's very simple. So it's just a linear scalar times your activation function, and that's it. And we use that to train spiking neural networks. And for the result, now I trained a convolutional neural network to classify the MNIST, and it works quite well. It's reaching 99% accuracy, and it also works on speech recognition. And I heard there are good and reinforcement learning people here, so welcome if you want to try it on spiking neural networks.